All right, today we are pulling back the curtain on your closet. We're going to dive into the hidden world and the frankly incredible amount of energy that's locked into the clothes we wear every single day. No, really, just for a second, think about it. That shirt you've got on, those jeans, where did they actually come from? I bet the answer is way more complicated than you think. Because turning a simple little fiber into the fabric you're wearing right now, well, it's a full-on industrial saga. It's a journey that chugs through huge amounts of water, a ton of chemicals, and of course, energy. We're talking sometimes enough energy to power your house for a day, just to make a single pair of jeans. It's wild. I mean, just look at this. This gives you a sense of the massive scale we're talking about. These are just enormous volumes of raw material, all sitting there waiting to be transformed. So let's follow that journey step by step. First up, we're going to uncover some of those hidden costs. We're going to see just how thirsty, how resource-intensive this whole process really is. To really get a feel for it, we're going to be detectives. We're going to follow one piece of fabric, from the moment it enters the factory as this raw, kind of boring material, all the way until it becomes a finished product. Okay, so our journey starts with what's called pre-treatment. You can't just throw dye on raw fabric. It won't work. First, you have to clean it and prep it. You can almost think of it like an artist prepping the perfect canvas before they start painting. And this whole prep stage happens in 3 key steps. There's singeing, then bleaching, and finally mercerizing. Each one of these plays a really critical part in how that final fabric looks and feels. First up is singeing. And yeah, it sounds pretty dramatic because it kind of is. The whole point here is to get a perfectly smooth surface by literally burning off all those little fuzzy fibers that are sticking out from the raw fabric. And what's so cool about this slide is you see the theory and then the reality side by side. On the left, that's the textbook diagram, right? You see the fabric winding through rollers and past these little burner icons. But then on the right, whoa, that's what it actually looks like, a literal wall of fire creating that super smooth finish. Okay, so after the fabric is all smooth, it has to be bleached. This step is all about getting rid of any of the natural color or impurities, creating this perfectly uniform white base that's ready to take on some dye. And the last prep step is called mercerizing. Basically, it's a chemical bath, usually with something like sodium hydroxide. And it does 3 really important things. It makes the fabric stronger, it helps it soak up dye way more evenly, and it makes sure it won't shrink or get all weirdly shaped later on. And we're not talking about just a simple dip in a tub here. I mean, look at how complex this machine is. You've got the entry, the impregnation, the stabilizing, the drying. It's a massive energy-sucking assembly line just to get the fabric ready. So let's move on and see what happens next. All right, now for the main event, dyeing. This is where your fabric gets its personality, its color. And it's almost always the most resource-intensive part of the entire process. It uses enormous amounts of water and heat, enough hot water to fill dozens of bathtubs for just one single batch of fabric. Now, to understand how factories try to be efficient here, you gotta know this one key term, liquor ratio, or LR. It sounds weird, but it's simple. It's just the ratio comparing the weight of the fabric to the amount of water in the dye bath. And the goal is always to get that ratio as low as possible, because less water means less energy to heat it all up. So, for instance, a pretty common liquor ratio might be 1:7. What that means is for every 1 kilogram of fabric you're dyeing, the factory is using 7 liters of water. The whole game for the industry is to try and shrink that second number down as low as it can possibly go. And you know, some companies are making some really interesting progress. Take Levi's. They started this whole waterless program specifically to go after this problem, and they found some clever new ways to get that classic look using just a fraction of the water. So one of their big innovations involves using ozone. It's pretty cool. By bumping up the ozone concentration when they're bleaching, they can completely get rid of some of the really water-heavy steps. On average, that saves about 12 liters of water for every single pair of jeans. And when you think about how many jeans they make, that's a huge deal. And here's another trick. Instead of washing the jeans in a chemical called potassium permanganate, they just spray it on the dry garments. Just that simple change lets them combine a few steps and boom, they save another 5.8 liters of water per jean. See how these little changes start to add up to some massive savings? Okay, so our fabric has been prepped and it's been dyed, but we are not done yet. The final stage is called finishing. This is where the fabric gets all its final properties, like its texture, its softness, or maybe it's made to be wrinkle resistant. And there are basically 2 ways to go here. You've got chemical finishing, which uses heat to bake special coatings onto the fabric. Then you have mechanical finishing, which uses physical things like steam and pressure to do stuff like make the fabric softer or pre-shrink it. And once that fabric is all finished, efficiency matters right down to the very last step, when it's all being stitched together. Now, this chart looks complicated, but the idea is actually super simple. It's just showing how much the time varies to complete different stitches. See how wide those boxes are, especially for the total time on the right? That means the process is inconsistent. By putting in better, more efficient motors, factories can shrink that box, making the process way more predictable. And that consistency means less wasted time and, you guessed it, less wasted energy. So we've been on this whole journey. What's the path forward? How does this massive, energy-hungry industry actually become more sustainable? Well, the good news is the solutions are already out there. This slide sums it up perfectly. We're talking about recovering waste heat from all that hot water and exhaust, using automation for super precise control, upgrading to those high-efficiency motors we just saw, insulating everything better, and using those advanced techniques like the ozone fading we talked about with Levi. And really, that brings us to the final thought here. The technology to do all of this, it isn't some far-off sci-fi dream. It exists right now. So the challenge isn't about invention anymore. It's about implementation. The real question is, how quickly can this giant global industry adopt these smarter, greener methods and change the story of the clothes hanging in our closets?